Alright, we're online. Cool. Alright, hopefully we get there. Yes, perfect. Okay. Hello, everybody. How's everybody doing today? Alright. Hello. How is everyone today? Good. Nice. All ready for the weekend, I hope? Whoop. Gotta grab that there. There we go. Hopefully everybody's got some nice plans for the weekend. Maybe going out. Excellent. I'm glad you are doing very well here today. We're here and we're doing things. That's good. We take some medicine today. There we go. Perfect. I'm doing great. I'm doing very well. Um, yeah, it's been kind of an unusual day up and down, but I think overall it's been a pretty positive day. I think everybody has. I hope things have been positive for you today as well. Yeah, Alyssa. Yeah, like I said, it's a positive day today. I think we all look forward to the weekend. You know, maybe not me because I'm a hermit, but yeah, you guys go out and have a nice time, and and things like that. I don't know. Hmm. Was thinking maybe I should go purchase a new car or something. But then I'm like, I only drive my car like twice a week now due to coronavirus. And it's like, well, I don't even know what the point is at this point. I mean, I own my car, so it's not like I can't trade it in. But I'm like, I was gonna buy a car earlier in the year before coronavirus, and then I was like, nah, it's not worth it. I'll just take the L on the car, just ride it out until it's dead. Excellent. I'm glad. If you're watching YouTube and some eats, there you go. Nothing wrong with that. You know what I like to eat for a snack? I like to make some tater tots in my little oven, and then I take those tater tots and then I put it in a bowl and then cover it with shredded mozzarella cheese just all over the place. I like layer it, and then I just eat it with a fork and stuff after I pop it in the microwave. That is that is some good eating right there. Some good snacking. Favorite color? Purple. Yes, purple's a really good color. Purple's my second favorite color. I like blue, as you could tell in the background there. Um, like sky blue. Purple is a wonderful color. Like I said, my second favorite color is purple, but sky blue because it's light on my eyes and you get a more open feeling when you have a sky blue wall. In my that's just me though. I mean everybody's got a thing. So, uh, but I just feel like my place is more open with the sky blue wall. You guys can ask whatever you want. I'll be happy to answer you. My favorite TV show? So I don't have TV. Well, technically, I guess I have TV, but I guess I have TV, but my TV's like sitting in my closet collecting dust for the past like 4 years, so it really hasn't done anything. Favorite movie of all time? Oh man. Yeah, I think I know because I've watched this movie more times than every movie ever. It has to be Spaceballs. Spaceballs, the movie. Yeah, I've watched that movie more times than I can remember. Spaceballs. Actually, we could say Spaceballs and the Lion King. Yeah. So you just got to go through each question which relates to a topic. So you got to go through. So for Alex there, Sarah. Yeah, you just have to go through the topics learned. Once you get the topics learned, you can move on to the next one. So that's for the entirety of the unit. That's correct. So they'll just ask you little questions by little questions by little questions to get you through certain topics that you'll need to learn. Man, what a day already. Whew. It was pretty hot today, so I was like, right before I came out here, I'm like, man, I gotta take a shower. You ever get that feeling like you feel kind of ick? You're like, yeah. When is the Alex homework due? The Alex homework will be due the day when I announce the test. So when I announce the test, that day of the test is going to be the due date. Um, you can call the bookstore and see if they have an Alex kind of like booklet or something. They may have like a little booklet for like the Alex code or something like that. Because I'm sure you're referring to financial aid and stuff. So they have the thing on that. There's no due date for homework on D2L. Yeah, that's correct. Yeah, assume to look at the due date on Alex. Right now, it's a tentative date. It's not the real due date until I make an announcement. So, and then I'll change it up. So, I'll let you, of course, know way beforehand before the homework's due. So, you try to find, yeah, call the bookstore there, Planet. Okay, call the bookstore and ask, hey, do you got an Alex code? For financial aid. You want to actually guide. Yeah, you wanna actually have them guide you because they do the paperwork for the financial aid stuff. So yeah, just to let you know. If you don't have financial aid, then you can just go through the Alex website. But if you do have financial aid, I know you would want to be the thing there. Yeah, yeah, exactly. It's just that the bookstore coordinates directly with financial aid, so it's kind of important to like negotiate the two so you get properly compensated for purchasing the code. Hello, Andre. How are you? Is there any way can we get well I have you yeah, sure. Let me hang on. Is this better? Is that better? Am I not I try and be soft because I know sometimes the volume can be really loud, or my mic isn't the greatest. So, but is this now a little? I mean, I can turn it up all the way, but I don't want it to be like having your ears bleed. I'll turn it up all the way and see what you guys think. Okay, that's turned up all the way. This is as far as I can go for mic stuff. Okay, well I'll leave it on there if you guys are comfortable with that. I don't got a problem with that. All right. You finally tuned in the right class. Nice. All right. Cool. Cool. I didn't realize my audio was low. I try, like I said, I try and keep it low because I'm usually pretty loud. So I didn't want to be like I said, making your ears terrible. I like all the way better. Okay, that's fair. From 0 to 60. Okay. All right. I'm sure we're going to have a few more people kind of join us as time goes along. Excuse me. Probably drink some pop there too. All right. Yeah, that's fair. That's definitely fair. I know you would want to turn me down, because I'm super loud and you whatever. So, I mean, look, morning, you could just hit the mute button. I know that's what you really want to do secretly. Okay, I understand. I totally understand. You're like, man, he's just talking too much. Mute. Just a. Hey, that's what math is. Equations appear with no context. Come on now. Let's not kid ourselves around here, okay? Muting people mute my grade. That's right, Ramil. It's not my problem. Don't worry about it. All right. Okay, let's go ahead and get started here for today. Welcome back to Thursday. End of the week time today. All right, so today we are going to go over another couple sections here. Last time we went over the syllabus and section 1.1, just talking about some of the basics here about graphing. All right, so we went over the first 4 questions from the handout from last time. Now, I did put an update on the announcements there on D2L. All the handouts should now be on there. So just as I promised from last class, all the handouts now should be on D2L for you to click on and either print out or download or whatever you want to do with them. They're all there for you. So if you kind of want to follow along here, we're doing the 1-1-1-5 handout. We did 1-1 already, so we're just going to start from in the middle. And then we'll also do the next section there, 2.1 as well. A lot of today is going to be like review stuff, so it isn't going to be, or maybe things you've seen in the past, or maybe you've just forgotten altogether. But it will be relevant for a lot of the things that we'll be doing later. So it's kind of important to kind of get to know it now and get a good handle on it because we'll be using it over and over and over again on several different topics. So certainly something to bear in mind. Okay, so what we're going to do here is, oh, by the way, before we get started, are there any questions from last time before we formally get started here? Again, type no in the chat if you want me to move on, or if you do have a question, please go ahead and type it out. Okay. Alrighty. So if there are no questions here so far, then that's just fine. We'll go ahead and move on here. We're going to start with all good, all good. All right. We're going to start with question number 5 here on the handout. which is the start of section 1.5. Okay, so I do understand any sections that we actually skip will not be reflected on the test as well. So again, 1, 2, 1, 3, 1, 4 will not be reflected. All right. Um, what is a quadratic equation? Okay, let's talk about quadratic equations because we're going to work a lot with this. We're going to see a lot of quadratic equations this semester in some form or capacity, so getting comfortable with this once again will prove to be fairly helpful. All right, so a generic quadratic equation is going to look like this. It's going to be ax squared plus bx plus c equals 0. So this is your generic quadratic equation. And a, b, and c, okay, a, b, and c are just some, at the end of the day, just some random numbers. Okay, they could be whatever you want, but they're random numbers. You don't really care what numbers they are. They could be fractions, decimals, whole numbers, whatever. But that's a quadratic equation in general. So what does a quadratic equation look like in general? With like specific examples, I should say. Say for example, let's say 3x squared minus 2x plus 1 equals 0. Okay, this is a quadratic equation. All right, so pretty straightforward stuff. Or let's put up another one here. Let's go with negative x squared plus 30x minus 159,327 equals 0. Okay. Yeah. Why those numbers? I don't know. I just kind of randomly picked it, and then it just kind of happened. That's usually how things go in the class. Magic happens, Hey, look, equations appear with no context. There you go. Good job. Um, all right, so these are examples of quadratic equations. Now, one thing to keep in mind here that is very, very important, okay, with quadratic equations. So I'm going to put a big note to this, okay? So note here, um, if we typically want to work with quadratic equations, we would like the equation to equal 0. Okay, so we may need to do some algebraic manipulation and stuff like that, and that's cool. But we want the equation here to equal 0. I'm going to make this a bit smaller here. You can read that. There we go. Okay, so that's what we want to be doing. So this is actually an important note because of the fact that this is kind of guide us to doing a lot of the things that we want to do. Again, in various different types of problems, is setting it equal to 0 and then doing stuff with it, in some form or fashion. Okay. All right. Let me grab this here. All right. All right. So that is essentially a quadratic equation. Yay, beans and rice. Okay. Now, let's go on to how we can solve for certain quadratic equations. Okay. So we're going to be using some of these methods we're going to be talking about right at the beginning are going to, like I said, appear quite often in other parts of this textbook. So again, having a good grasp of how we can work with this is going to be very fundamental into having you succeed in other concepts here later on. So let's talk about how we can solve quadratic equations using various methods. Okay, so how do we solve quadratic equations by factoring using the AC method? All right, so let's talk about the AC method here. Let's see how we can work with this, and let's see what we can do. All right. Okay. Yeah. All right. So let's go with an example. I want to show off an example, and then I'm going to go ahead and describe the steps behind said example, and we'll see exactly how that fits in. Okay. Okay. Yeah, I can do that one. That's fair. So let's go with this one. All right, so let's go with x squared minus 3x minus 10 is equal to 0. All right, so let's say this is our guy right here, and we want to be able to. Our goal here is to solve for x, and for us to solve for x, we're going to use this AC method here. Now, in this case, the AC method is pretty straightforward, but you're not always going to have a straightforward answer necessarily all the time. So I'm going to break this down one piece at a time, and you're going to see exactly how we can come up with our two answers here for x. Now, you probably, if you know this already, it shouldn't be too hard, but what I'm showing you here is the generic way of doing any and all examples here of quadratic equations. Again, one way of actually approaching that topic. So let's go to step one. All right. All right. So step one is first identify A, B, and C. Okay. So identify A, B, and C. All right. So I'll just tab over here, and you could write that on a sheet there. So can anybody tell me what is A, what is B, and what is C according to our equation here? Okay. Okay. All right. So let's talk about this here for a second because I like the answers that I see here. Okay, now let me go to Alyssa's answer here. So the thing that we want to look at here specifically, and just to give you a friendly reminder, A, B, and C here are going to be the coefficients, or coefficients is just a fancy word for the number in front of something. All right, so in this case here, A, B, and C here are A is going to be the number in front of x squared. So the number in front of x squared, another way to say write this out, if you want, what can be helpful for you here is that you can just put a 1 there for 1x squared, and then you could recognize that a would be equal to 1 in this case. So if you want to rewrite it like this, and I see a lot of people who do, um, because again, it's just a matter of just organization stuff, and I think that's cool. So, a would be equal to 1 for that reason. So just remember, the number in front of x squared is 1. That's all we care about. So we don't care about the x, we don't care about the x squared, just the numbers in front of it. We also don't forget you also want to keep the sign there. So you wrote 3x, remember to keep the sign there. So for B, so remember to keep that sign there. So I'll actually put that as a note up here. Put a note, remember to keep the sign. Okay, all right. So just putting as a little side note there for you guys. So again, just making sure that it's pretty clear about how things go. And C here is equal to, again, minus 10. That is correct. Minus 10, no problem. All right, so that's how we can identify A, B, and C here in this particular quadratic equation. So again, like I said, today is kind of like kind of shaking out all the cobwebs and kind of getting out all the old material you may have forgotten or things like that. So it's fine. This is exactly why I like to cover. Why we're covering this is just to kind of get a good foothold once again for things that may be long forgotten. So we're gonna bring it back from the subconscious and bring it forward to the conscious. Okay, that's what we're trying to do. That's the goal. Okay, let's go to step 2. Step 2, multiply A times C. Okay, so that's what we're going to do here. We're going to multiply A times C. All right, simple enough. So A times C here is equal to 1 times negative 10. So that equals negative 10. Okay, so that's all we're doing there. It's just pure basic stuff things that work. Okay. Yeah, get rid of this because that's annoying. Okay, there we go. Much better. Okay. All right. So that's what we have here for AC. Let's go to step 3. Okay, now step 3 is kind of the big part of the process here. So let's talk about how we can use the AC method here. What you're going to do here for step 3 is you're going to find two numbers that multiply to, and I'll put here A times C, and add up to B. So it has to satisfy both. So find two numbers that multiply to A times C, which is what we found in the last step, and add up to B. So what some people do here as part of their work is they may write, again, like a blank here, and then times blank, okay, should equal minus 10. And then here on, say, this next line here, we have the same number here plus a number here should equal minus 3, since that's what B is. Okay, so that's what we have here. Let's go ahead and fill in these blanks here. Again, they have to be the same numbers, okay? So they can't, both of these can't be different. They have to be exactly the same, okay? So let's put a note with that there. Note, must be same numbers. Okay, so it must be like, if it's 3 and 1 on the top, it should be like 3 and 1 on the bottom, for example, okay? That's what it has to do, all right? Okay, so what two numbers satisfy this condition here? Okay, nice. That's correct. Let's see if I can find my mouse. There we are. Okay. So minus 5 is correct, and 2 is also correct. Okay, so minus 5 is a winner, and 2 is also a winner. So we're going to put minus 5 here, and a 2 here. So minus 5 times 2 is minus 10, and minus 5 plus 2 is minus 3. Now, if you weren't sure about how that works out, that's okay. What you can do is just kind of trial and error a combination of numbers that are going to work for both cases. All right, so if you said 5 and minus 2, well, you notice quickly that the first one would work. That indeed is minus 10 if you multiply that together. But then you say 5 plus negative 2 is plus 3, and then you'd realize, oh, I got the signs flipped around. Now I should have minus 5 and 2. Okay, so do a little trial and error. Sometimes it can be a little tricky at times with the AC method, but you know, a little few combinations here and there, and eventually you're going to find it if it works out that way. Are there any questions so far in the process? Okay. Just want to be sure that it's clear and that, you know, this is something that I'm going to go to in terms of going to the well many times. So you'll see me kind of go to this well a few times during the course of the semester in several examples. So just don't be surprised that I use this, you know, multiple times in some capacity. All right, let's go to step 4. So we're going to rewrite the quadratic equation. Actually, let me say it this way. Sorry. Rewrite specifically. Let me be specific here because I think that would be unclear if I wasn't. Rewrite bx. All right. So the bx term right? Using the two numbers found in step 3. Okay? So rewrite the bx term. So what we want to do here is, we want to rewrite the equation here. All right? So let me go ahead and show you what that means here. So I'm going to keep everything the same here, all right, except for that middle bx term. So the x squared here is going to be the same. That part isn't going to change, okay? But what is going to change is that in the previous step, I found -5 and +2. So I'm going to put -5x, just like so, and plus 2x, just like so. And I'll put -10 because I didn't touch that, and that equals 0. So now I've rewritten the equation here just like that. Okay. All right, let's go to the next step here, step 5. I know this seems like a lot of steps, but once you get used to it, it's pretty fast. All right, next what we're going to do is factor by grouping. Okay, so that's the next step here. Now, what exactly does that mean? Well, there is a reason why we use the AC method in a very particular manner. All right, and that is because we can group the terms together and factor by grouping. Now, what does that mean? Let's go back to this guy right here, what we wrote out from before. So what we're going to do is we're going to take the first two terms here. We'll put a nice big set of parentheses around the first two terms. And then these last two terms, we're going to put a nice big set of parentheses around these last two terms. Now, one thing to keep in mind here, and I'll go ahead and copy paste this. One thing to keep in mind here is that notice I kept this sign here in the middle. Okay, so again, I'm going to put a note here. Note, keep the sign in the middle. This proves to be rather important. Okay, so this plus sign here, when we're going to do the factoring, is going to come right down. So you don't have to worry, yes, you do have to worry about sign changes, but you know what sign you're bringing down at the end of the day. So that's where things are kind of important there. Okay, now we see that we have two groups. All right, so the first group here, we have x squared minus 5x. So taking a look at that first group there, what can we factor out of that first group? All right, that's correct. We can factor out an x. Perfect. Now, more importantly, I agree with everybody here. What do we have left over when we take out the x? That's correct. X minus 5. X minus percentage is not right. All right, x minus 5. That's correct. Okay, so why is that important? Well, we're going to see exactly why this is important in just a second. Well, let's look at our second group here. Now, notice we have the plus sign here in the middle, so we're going to bring this plus sign straight down here, just like so. What can we factor out of this second group here? All right, very nice. That's right, Jess, very good. So when you factor out the 2, you're left with another x minus 5. All right, so let's take stock in what we have here. So if you notice here, we have, again, we have x times x minus 5 plus 2 times x minus 5. And then finally, we can then factor out the x minus 5 because we have an x minus 5 here in the first term. We have an x minus 5 here in the second term. So we get our final factored form here of x minus 5. And then x, and then this plus here, 2. So this is what we have here for step 5. Now you're probably saying, oh man, it was so easy. I already knew that from before. I could find that, lickety split, no problem. And I'd be like, yeah, that's true. You could. But the problem is that, again, this is used for, again, this is an easier example, but this method here can be used for any combination of A and C if we are able to do so. So again, it doesn't necessarily mean A is 1. A could be 4, and then we're going to have a different possible combination if we can find it using this method. So that's why I'm kind of showing off, even though it's easy to get to this result, and I understand that. What I want you to understand is kind of like the macro, like the big picture sort of perspective here. This can be used in pretty much every quadratic equation if it's possible. So, and not always possible, but we try that first and see if we can work with it. All right. Now let's go to step 6 here. So we're going to use the zero product property here. So remember, at the end of the day, we still want to solve for x. That is still our goal here, is to solve for x. All right. So what you're going to do here, simply put, zero product property says just set each factor. Now, I'm going to be very specific here, okay? I'm going to be really specific here because it is kind of an issue with a lot of people who do factoring in this class, and it's a common mistake I see quite often. So I'm going to be very specific here. You're going to set each factor equal to 0, but I'm going to be more specific. Set each factor that contains an x equal to 0. Now you're probably saying, well, whoa, why would you say that? That seems kind of stupid. And I'll be like, yeah, I would kind of agree. But a common mistake I see a lot on tests is that what if happens if you see a 2? Let's say there was a 2 times all that stuff. Okay, so if there was a 2 times all that stuff, some people put 2 is equal to 0. And I said, no, you can't do that. That doesn't make any sense. 2 can't equal 0. But that's why I say each factor that contains an x, but this doesn't contain an x. This is just a number 2. So we don't set that equal to 0. So you see my point. My point is that that's a common mistake I see quite often when it comes to factoring, is just like, putting too much in when you don't need to. So hence why I make that little distinction there, so you don't get tripped up on problems that may occur later on down the line, that where you kind of get to that point. So yeah, some of those pitfalls there we want to kind of avoid. So all right, so in this case here, this isn't rocket science after this, I promise you that. So step 6 here, we're just going to set set x minus 5 here is equal to 0, right? And we'll also do the same thing here for the other one. X plus 2 is equal to 0. I'm just going to paraphrase, blah, da, 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 dot, dot, dot. And so here we're going to end up with 2 answers. You just add 5 on both sides, and then here we're going to get x equals 5. All right, and this other one here, x equals minus 2. Okay, so not too hard after that. So our 2 answers here are 5 and minus 2 respectively. So by in itself, it's not a very hard example, but again, it is an important example because of kind of like the reasons I kind of listed out. I'd be like, hey, this is going to come up again and again and again, so let's let's work with that and see what we can do with it. Okay. Are there any questions about that so far? Okay. Okay. Hopefully everybody's kind of got that a little bit. Give me a tissue, please. Ooh. Ooh. Brutal. Okay. All right. Okay. Uh, Next we're gonna do another example here, but this time you're gonna guide me. So I get to play the lazy man, and I'm gonna put another example down here, and then you tell me how we do this problem, because you know, I'm super lazy in reasons. Okay, so this is what we're gonna do. Let's put down a new equation here for you guys so we can see exactly how we're going to met it out. Yes, that's an excellent problem, and that is the one I want to do. That's the one I wanted to do. That's the one that we'll get. All right. So here's our example. Okay. All right. So let's go through the steps here. You guys tell me, what should I do first? What should I do first? Let's go back up here. Actually, I'll make this a bit smaller on purpose so you can kind of see how things go. Or if you've already written this in your notes, then that's good. Yes, okay. Both those answers spot on. We want to add 3 to both sides in order to get it set equal to 0. That is correct. Now, just for the purposes of, you know, just kind of like the ease of use, I know I could add 3 and add 3. I'm just going to highlight that by doing this. All right, so you'll see this kind of often to kind of highlight the work behind it. So this is not times plus 3, this is just adding 3 on both sides. So you'll see me do this often because of the inflexibility of the program. So just wanted to point that out to you guys and be like, oh, okay, that's what he's doing. So that's what we have here. Perfect. All right, very nice. 100% guaranteed, agreed. All right. All right. So that's the first part there. We want to have it in quadratic form. Now I'll make this a bit bigger, so now you can be able to see it a bit better. All right, there we go. Okay, and what's next? What do I do next? Okay, what's A and C? Yeah, what's A, B, and C? I agree. Well, what's A, B, and C? Okay, so A is 4. Ah, that's not what I wanted there. All right, B is going to be minus 13. Oh, careful there. Careful there, Ermil. Yeah, B is minus 13 there. There you go. There you go. All right. Oh, that's okay, my man. It happens. I mean, it happens. Okay. So B is minus 13. That's cool. That's cool. C is 3. That's correct. Okay. Very good. And then, as was stated next, we want to do AC. Okay. So if we do AC here, AC is going to be 4. So let's do A times C, which equals 4 times 3. So that equals 12. Completely agree with that. So far, so good. Okay, so here we got our step 1, step 2. All right, cool beans. All right, so what's next? Okay, we got to find 2 numbers. All right, well, What two numbers are they, and what do they have to do? I agree with that, but let's expand on that a bit further. -12 and -1. So let's that's correct. That's correct, Gura. Well, so what we want to do next here is that we find those two numbers. That's right, Hannah. So we want to find those two numbers. Both of them have to multiply. So -12 times -1 equals 12, which is what A and C are, and -12 plus -1, plus -1 equals -13. All right, so that sounds great. 100% agree. There you go. It isn't a negative, though, 12? Are you saying this number here should not be negative? What did I put something wrong there? Hang on. What did I do wrong here? I'm just making sure that I put that correct. So -12 times -1 is +12, which is what AC was equal to. Okay, so the only way we can get a positive is that both of them are negative, because the middle number here of B is negative. Okay, so yeah, I see your point there. It's like, oh, they have to be positive, so they can't be negative. Uh, So yeah, I see your point with that. I see your point with that. But that's the thing, is that they can both be negative, they can both be positive. Okay, you have either one of those choices. All right, so it's not like you're limited to just two positive numbers only. You can have two negative numbers and still satisfy this part here. And they still add up to -13 because that middle term there is negative as a result. So just be careful there. Yeah, don't limit your choices there. Remember, they can both be positive, both be negative, or a mix in between. Okay, okay. Yeah, people use the diamond method. I didn't learn the diamond method. I just basically kind of did trial and error. But if the diamond method works for you, then go ahead and use that. I'm not going to hate you for it. I think that's perfectly cool. All right. Yeah, the diamond method is a method that some people use to kind of see what the adding up two numbers and stuff like. I've seen that before on papers and stuff. So um, yeah. All right. If you're not sure what it is, don't worry about it. Just work with the methods that you're comfortable with, and I'll be cool with that. Okay. Well, now that we got past that, well, what's next? That's correct. If the method is consistent and you get the answer, I'm cool with that. You don't have to use my method. My method is not the method. It is a method, but not the method. Anybody else who tells you otherwise is a liar. All right, let's rewrite that BX term. 10,000% agree. All right, so I'm actually going to write it over here and then copy paste it over there. All right. Okay, so let's go ahead and rewrite this. We get 4x squared. All right, and then we got -12x minus 1x plus 3 equals 0. Okay, so we rewrote that BX term, ba-bam, using our two numbers, just like so. All right. And correctly stated here. All right. So Dala, I want you to be really careful about that what you just wrote there. All right? That's one part you need to be a little extra careful about. So you write 4x minus 12 and negative 1x plus 3. And the way you wrote that is almost correct, but just not quite. Remember, one of the important things here, and again, like I said, it's kind of like those little details there. Remember, you want to keep this middle sign separate. So where you want to put the parentheses here actually is going to make a difference in this problem. Is actually, you're going to go ahead and put the parentheses like so. All right, where you have the minus sign separate than that of the 1x plus 3 on the right-hand side. So that's what we want to have here. Yeah, all right, good. We're doing fine. So we're on step 5 here, I guess. Guess I should put the, yeah. So just be a little bit careful about that, so that way you don't get tripped up on the signs here. No, it is. That's a good question. No, it is not a plus because the two numbers we wrote. Look what we wrote for our two numbers. We have minus 12x and we have minus 1x. So it's not always going to be necessarily a plus in the middle. It will follow the sign based on how you wrote out your bx term when you rewrote it here in step number 4. So you cannot make an assumption that it's always going to be plus or it's always going to be minus. It'll just be based on how you rewrote the bx term here in step number 4. So let me stop here for just a second, and I want to put a kind of a warning here. All right, I'll put a warning here. One of the biggest things in mathematics that can be fairly difficult. So the plus negative 1x plus 3 is wrong. Technically, that's correct, but you actually want to keep that middle sign. You want to keep that sign in the middle for a very important reason. Okay, if we're gonna be, it's not wrong per se, but then there is a kind of a pitfall doing that because people tend to forget something in the middle of that process. So I want to try and make it as easy as possible in that regard. So I'll show you what I'm talking about here in just a second. All right, but what I want to kind of warn about here is a lot of people make assumptions here that it's magically this is going to happen. In mathematics, you never assume. Look at what you got in front of you, but you never assume. One of the things about math that is really rough is that once you make that assumption, it would just be like a whole cascading effect, and then that would be a little bit rough there. All right. So make sure you don't fall into nasty traps. That's why I put never assume in that case. All right, so the next step it would be, okay, so I agree with the 4x there. All right, so the 4x is correct. And yes, indeed, we have x minus 3. All right, so that part is true. Now, let's take a look at what we have here. We have this minus sign here in the middle. So I got to bring down the minus sign here like I have up here. Hello, I'm in the middle of class, but feel free to drop in and stop on by. No problem. Okay, no, it's okay. Sit back, relax, and have a nice time. All right. All right, so we brought down the minus sign here in the middle. So because we brought down the minus sign here in the middle, we have to change the signs inside of these parentheses here. Okay, but there's also, that's correct, but there's one more thing I actually do want to do. Absolutely true. There's one more thing I do want to do, and that is, you notice that there's nothing in common between 1x and 3. All right, there's literally nothing in common except for one number, and that is the number 1 itself. Okay, so that's kind of the other thing I kind of wanted to talk about here. Oops, x minus 3 here. This needs to be x minus 3. The signs need to change. So, but you see exactly how things kind of work out here in this particular case. So I'm going to put a kind of a note with this as well. That is a note. Let me put that in bold. Note: if nothing in common, factor out a 1. Okay, so one of those little things there is that, okay, x and 3 don't have anything in common, but you can factor out a 1 every time, and then you can see what that'll factor to at the end there. So that makes it a little bit more convenient to do so. So our result here is going to be, let's take a look here. It'll be 4x minus, it'll be, x minus 3 and 4x minus 1. Why does the sign change? Very good question. So the sign changes because we took out a negative by bringing this negative sign down. That's why the sign changes. So it was negative before, so now it became positive. This was positive, so now it became negative because of this minus sign that I brought down. Couldn't you just take out the minus 4? Or are you talking about this over here? Oh, okay. That's a good question there. What about taking out minus 4? Well, there is a particular reason why I don't want to do that here. It's actually easier to go ahead and have the coefficient for x squared be a positive term. So for calculations and whatnot with quadratic equations, if a is positive, it's like 10 times easier to work with that than a negative term, than a negative coefficient. So it's a good practice to keep it positive, just because you don't have to do as much work later on. So basically, a lot of the things that I do are basically for ease of use. It's not that it's wrong, it's just that, through my experience, it's just a lot easier to have a being a positive number, once you kind of get down to the nitty-gritty things of it. So I hope that makes sense there. Are there any other questions before I move forward? I hope that makes sense for everybody there. Let me bring down a note here. Nothing to be sorry about. No. Ask questions. Ask questions. That's what I'm here to do. I'm here to answer your questions, so that way it makes it clear for you. Look, this isn't about me. It's about you guys. Okay? You gotta learn the if you gotta learn the material, then asking questions is how we're gonna learn together. Okay? More so you than me. So yeah, it's not an insult. It's not an insult if you're not sure about something. It's all about understanding the material at the end of the day. So trust me, just stop me, because if I'm going too fast or it's too confusing, just stop me in the middle and say, hey, I don't understand this. Can you explain this again? Hey, can you tell me why this happens? Hey, that's fine. That's what I'm here to help you with. All right. So, there's no hate. Trust me. No hate, just love. All right. That's how it works. All right. So I'm just writing a note here. Remember to bring down the sign in the middle. All right. This negative sign, and change if negative. Oops. All right, let's take a look here. I'm confused why we plugged in the 12 and the 1. but like my brain. Oh, okay. So we chose. All right, all right, that's fair. So the reason why we chose minus 12 and minus 1 is to satisfy step 3, which was, once again, these were the two numbers that multiplied to a times c and added up to b. So we had to say minus 12 times minus 1 was positive 12, all right, which was, again, 4 times 3, that was AC. And then minus 12 plus minus 1 was minus 13, which was the middle term here, which was minus 13, that was B. So that's why we went ahead and rewrote the equation here with the minus 12 and the minus 1 here, and then did the factor by grouping. So yeah, it's just this kind of like that middle part there. That's kind of the trickiest part, is once you rewrite the equation. But once you get down to that, as you said, yeah, the end is not so bad after that point. So I agree with that. That's, like I said, that's the toughest part there. Doing kind of like the trial and error stuff. But once you get past that, it's like, all right, I'm in easy street after that. So. And Blueberry says, yeah, solve for the zeros. That is correct. Absolutely spot on. So let's go ahead and solve for the zeros. All right. So again, we're just going to set x minus 3 equal to 0. And so I'll just kind of paraphrase a little bit here. And we also have a 4x minus 1 equal to 0. And again, you just do some simple algebra here for both of these. So we're going to find our two answers here. X is equal to 3. And then if you do add 1 and divide by 4 on both sides, x is equal to 1/4. Okay, so positive 1/4. And those are our two answers for that problem. Any questions about that? Okay. All right. Well, let's go ahead and move forward here. All right, and let's go ahead and do the next question. Oh, why do we need to find the x values? Because we're still solving for x here. So x is going to be the roots of the quadratic equation. All right, so it says to solve for x here, so that's why we need to solve for both of these. It basically says if I plug in 3, it makes that quadratic equation 0. If I plug in a fourth, it also makes that quadratic equation equal to 0. So those are the solutions of the problem there. Yeah, so you gotta be. That's the problem with like a negative in the front, is just that the issue is that, yeah, things get mixed around really easily, and so it causes you to get more confused than really helping. So it's like, that's why I like a being positive, or if I can change it to a positive, so it makes my life 10 times easier to actually do stuff with. So remember, folks, the lazy way, the best way. All right. You've been doing your homework assignment. You're like, yeah, turn on some. Yeah, it does get. You're like, I will watch some Netflix, do some math homework. I'm like, oh, this is so easy. All right, let's watch some Netflix. Cool. You know. Easy time, easy life. All right. All right, let's look at the next part here. How do we solve quadratic equations by the square root property? All right, this one here is actually fairly straightforward. It's not so hard, but let's take a look at a couple problems here, and we'll see exactly how to work with them. All right. So I'm going to do this first one here. Yeah. So I'm going to go through these a little bit quicker because there's a couple of things I want to show off, and that's about it. So let's see here. There's a few highlights certainly to be had because we do see this. Why would I want to write that? That's terrible. All right. Okay. Let's go over this. So here's our example. Okay. All right. So we have the quantity 2x plus 8 squared equals 27. Okay. That's what we have here. All right. So our goal here is to go ahead and solve for x in some capacity. I'll move this down. All right. So if you see here, we have a quantity that's squared. All right. Working with the squared is a pain in the butt. Now you could technically multiply this out and be like, all right, this is 4x squared plus blah blah blah. I don't really care. I want to be able to do it the shortest way possible. And the shortest way possible is to remove this squared using our square root. So what's the first step here? Well, let's take the square root of this entire thingamabob. But of course, anything that we do on one side, we're going to have to do on the other side, right? Everything's a balance in algebra. It doesn't matter. So here, we're going to just take the square root of both sides, just like so. All right. So what happens here, if you've probably done this before, is that the squared and the square root will cancel each other out. And that's exactly what we're looking for. We can just get rid of that squared term so we don't have to deal with it again. So we're just left with 2x plus 8, all right, on the left-hand side. All right. Now, how about the right-hand side? The square root of 27. What is that going to be? What's the square root of 27? Hmm. 5.19. No. That would be a decimal. 3 times 3 times 3, that's 3 too many. 5 times the square root of 2. Not quite. Just 3. All right. I'm glad I asked this question because this is exactly, well, I'm really happy I asked this question. It seems that's okay. Tiredness is okay. That's why we're here for. We're just here to review. So no pressure, no problem. Okay. All is forgiven. So remember here, the cube root is 3. That is correct. So remember here, you'll need to simplify square roots. 27 is a great example of simplifying square roots. So remember, to simplify square roots, or any root for that matter, we need to find a number we can take the square root of. In this case, remember that 27 can be re-represented as 9 times 3. In square root land, remember that we can split up square roots into 2 parts. So this can be 9, and then this can be 3. Okay. So then we have the square root of 9, which is 3, and then we have 3 square root of 3. All right. Any questions so far about that? Now the next, oh no, okay. That's fine. Good, good. Glad you're remembering it now. Excellent, excellent. Okay, now I'm going to sound like an infomercial here. And I'm going to say, but wait, there's more. All right, so there is more to this problem than meets the eye. Okay, now one thing about math is that sometimes in certain concepts, it can be very arbitrary. And this is definitely one of those times where the arbitrariness kind of, oh, you'll tell me that for free? Do I have to pay $5 in order to get more compliments? I appreciate it. Thank you. All right. Now, what? Like I said, math is pretty arbitrary, and this is like one of those arbitrary times. So, oftentimes, what you're going to hear me say is that I'm going to add one more thing to the mix here. I'm going to add plus or minus. Okay, plus or minus has to come into play. All right. So we actually are going to have plus or minus 3 square root of 3. So what you're going to hear me say throughout the course of the semester is some concepts will only use, say, the positive square root. And some concepts here, like this one, I will often say this. I will often say, let me go plus, no, that. So I'll say plus or minus is in play. All right. So I'll often say that in lectures just to make you note that both the plus and the minus answer are both factored in. All right, so that is very important here when we actually want to find the final answers, because a common mistake is you only take the positive answer and then you run with it. But in reality, you actually have two answers and not just one. Okay, in this case. Some other cases, it's just the positive answer. And of course, I will certainly let you know that if that's the case, then of course I'll certainly let you know that only the positive answer matters. So it depends on which concept that we kind of cover. If plus or minus is in play, or it's not. Okay, so it's not always clear, uh, but it's what level math is this? This is college algebra, Blueberry. Um, uh, but yeah, it's not always clear, but I'll certainly make a note every time. Okay, now the next thing that we want to do here is we want to go ahead and solve for x here. So we're going to subtract by 8 on both sides. So I'll subtract by 8. Okay, so here I'm going to have, and I know this is going to look a little weird, but hey, it is what it is. So here I'm going to have 2x equals, and I'm going to have negative 8 plus or minus 3 square root of 3. And then after that, we'll divide everything by 2. Okay, so divide by 2. And so we're going to get a final result here of x is equal to, there you are, negative 8 plus or minus 3 square root of 3 all over 2. And so that is that's the work behind how we get to our final result there in that case. Okay. Sometimes I don't know what the computer will want necessarily. It may want you to say another way you can express this answer. So just for your reference, you could also do negative 4. I sometimes the computer can be, I think you guys know that sometimes it can be very choosy about how it wants its answers. So if you wrote it like this, that would be certainly acceptable as well. I don't care either way, but that's me because it's the same answer regardless. But again, if Alex is a little picky about that, then you just take it that one extra step. I don't suspect it should be in this case, but again, I don't take chances. So just to let you know. Any questions about that before we move forward? There's one more example I want to do of this, and then we'll move on. Yeah, yeah. That's why I make these notes, because I'm like, man. All right, let me go ahead and put this one down, and then we'll move on to the next next question there. All right, so all right. Okay, so here's the next example. 2x squared minus 7 equals negative 15. Okay, so what do I do first? Add 15. Now, normally that would be okay, but this is just a 1 squared on the left-hand side. So I wouldn't disagree with that. I wouldn't disagree with that, but it's actually, Jess, I wouldn't disagree with that, but actually, it's actually easier to move the 7 to the other side, because then we'll end up with the same situation like we did in the last problem, where we have like something squared is equal to some number. So that's why I'm actually doing it that way. Now, if there was a middle term like a 3x or something, I would totally 100% agree with you, Jess. I would add 15 to both sides, no questions asked. Like I said, we're just trying to find the easiest way to net our answer. So I'm just saying, that's why I'm choosing it in that direction. But I wouldn't argue with you if we had a middle term at all. So just pointing out the differences there about why I'm choosing it to do that way. Okay, so here we get negative 8. That's perfectly fine. All right, next we got to divide by 2. That has to come next, everybody. Okay, and so here we get x squared equals minus 4. All right, bueno. All right. All right, what comes next? Ew, I know. It's pretty gross. I ain't gonna lie. It's pretty awful. But I gotta keep going. So, what do I do next? Okay. So we're going to take the square root of both sides. This I totally agree with. All right, right? Now, yep, absolute right planet. We're gonna cancel out that exponent there, and that'll just leave us with the x that we're wanting here. Now we have the square root of minus 4. The square root of minus 4, what is that? Ooh, that's close. Blueberry, that's really close. Really close, everybody. So I agree. Yes, there you go. Very good. That's right, Blueberry. Plus or minus 2i. So 2i is correct. Okay, but remember, plus or minus is in play. So we have to take the minus 2i also into account. So all you had is some really good answers there. So just to break this down here once again, because maybe it's been a while. Again, square root of negative 4 can be, ooh, not that one. That's the wrong one. Can be rewritten as the square root of 4 times the square root of minus 1. Now, obviously, we can't take the square root of minus 1, but it does have that set definition there of it being equal to 2i. All right, I is equal to the square root of minus 1. So, again, So just don't forget about that. That was that concept quite a while ago. So, but we also have to include the plus or minus here as well. So our answer here for this problem is going to be plus or minus 2i. And let me see if I can get this highlighted. There we go. Okay. Actually, what am I doing? All right. Let me. Should probably just highlight that whole thing. There we go. Yeah, that can be a little bit. Yeah, that's why I'm kind of like that's why I'm kind of putting back in the habit of putting plus or minus. Like I said, certain concepts use plus or minus, and certain concepts use just plus, and that's why I'm making the distinction between the two. Why is it plus or minus? Because you can't rule out that. All right, you could put positive 2i. That one's pretty easy to see. But if you take anything squared, right? So it's the same idea as if you did this, right? And this is why it's plus or minus. The reason why it's plus or minus is if I did 1 squared, all right? 1 squared is equal to 1. But it's also correct if I said negative 1 squared is also equal to 1. So it has to be both plus or minus, right? You have actually two answers, not just one. Right, so it's the same exact idea. Because it's squared, that's why we're forced into that situation. So I guess I'll put a note here as well, and we'll put a nice little note here. Note, I is in play. So we have imaginary numbers too. Okay, so imaginary numbers are in play. All right, so we have plus and minus, and the i's are definitely in play. All right. Oh man, this is heavier than I thought. All right. Okay. All right, let's go through questions 8 and 9. Let's get through these a little bit quicker. Maybe question 9. Hopefully we can get to a little bit of the next section, but we'll try. All right. In any case, let's look at question 8. How do we solve quadratic equations by the quadratic formula? All right. So what is the quadratic formula? All righty. Let's go ahead and put it down here. So the quadratic formula here is going to be, I have it, what's nice about this is they actually, I think they have it on here. Yep. If you want to find the roots for x, then here we go. Ba-bam. Instant quadratic formula. Lovely. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. So if we want to solve for x and the roots for a particular quadratic equation, this is what we have to plug in the numbers for. So I want to put one note with this though. So the big note here is this, use this as a last resort. The reason why I put that here specifically is because factoring is significantly easier and takes less time. Doing the quadratic formula, you can easily mess up because of sign changes and everything like that. So you don't want to actually catch yourself doing that over and over and over again necessarily for every problem. You're going to get the right answer, but with so many signs kind of floating around, it can be a little bit cumbersome. So I use it as a last resort if I can't figure out what it factors to, or if it's just not possible with regular factoring practices. So try the factoring first. If you can't find a lazier method, then go to the quadratic formula after that as the last option. Okay, so let's do an example here, and we'll see how things work. I'm just going to do one example here because I don't suspect this to be super tough. So, but just a couple highlights certainly, of course. Let's do, which one would be good? Okay, that's fine. Oh, change that up a bit. All right. So let's go with this. All right. So we got x squared plus 4x plus 2 is equal to 0. Okay. So if we have x squared plus 4x plus 2 is equal to 0, now you could try the AC method, you could try factoring things, but they're not two numbers that multiply to 2 and add up to 4. That's not going to happen, okay? Not with conventional numbers. So we have to use the quadratic formula here because I can't figure out a combination that satisfies this for, whatever reason, okay? It's just not happening, all right? So let's go ahead and take a look here and see what we get. So what we want to do here is first just let's identify A, B, and C. So A here is 1. So again, if it helps, okay, once again, as I stated earlier, if it helps, put a 1 in front of that x squared, so that way you're like, oh, okay, the A is going to be 1 here. Again, a lot of people like to do that. Yeah, you can use a calculator. I don't care how you use the calculator, that's fine. It's cool. I'm down with using the calculator whenever. So I encourage it actually. So don't worry about what Alex says. Just roll with using the calculator there if you need to. Okay. Yeah, man. No, it's not realistic to have idiotic numbers and then be like, oh, I don't know what to do, and it's like, oh, well, that sucks. Yeah, idiotic numbers just becomes too cumbersome in your brain, and then you feel like it's melting. Would I write it as ax squared plus bx plus c equals 0? Yes, it is already in that form, x squared plus 4x plus 2. All we're doing here is just identifying what a, b, and c are specifically. So a would be 1 because that's the coefficient in front of x squared. Okay, so just that number in front of x squared is what we're looking at here. B would be 4, and c would be 2. That's correct, yes. That's the generic form of all quadratic equations. Yes, that's correct, Blueberry. Okay, let's start filling in the blanks here. Okay, so we have, let's see here, we got negative b, so I'm going to put negative b, so that's negative 4. Let's see here, plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so this is what we have here for our number substitution. Okay, just like so. Okay, now if you take a look at what I did here, I may have mentioned this last time, but I'll mention this again anyway. And if I didn't mention this last time, I apologize. But look what I did here for this formula, and this is actually going to be, now, by itself, it's not hard about what I did, but it's a common mistake I see quite often here in algebra, heck, even up to calculus or whatever. I always see this same mistake quite often in problems, and that is when you substitute a number in, you should always be sure to put parentheses around it. Even if you don't think it's necessary, it's very important because signs could change in the middle of the problem, and you can't make the assumption that they will or they won't. Okay, so you just put it in parentheses here. So one of the things I stress on very highly, from here to calculus or whatever, it doesn't really matter what future math class you take or future concepts we do. Always put parentheses around what you substitute. This by itself, this little factoid here, is probably saved my bacon quite a few times when I was learning math. because it made a lot more sense that I could organize my data and see the sign changes for myself. So I ain't gonna lie, this actually significantly helped me get better in math, just that one little fact. Because so much of what we do is substitution. This is section 1.5. 1.5. Okay, well, let's go ahead and solve for this stuff here. So we have -4 plus or minus, here we go, 16 minus 8. And I'm going to put that all over 2. Okay. All right. Let's go ahead and clean this up a bit. So here we get -4, -4, plus or minus the square root of 8 over 2. Now the square root of 8 can be rewritten. All right, you can rewrite the square root of 8 as 2 square root of 2. So we can write 2 square root of 2, just like so, over 2. All right. Okay, now there is one more part here I do want to show off here, and that is sometimes simplifying here. Okay, so here's another mistake I see some people do, and again, just bad habits, just kind of getting them out of the way. When you want to simplify this, all right, this is completely simplifiable, but the way you simplify this is you split it up into 2 fractions. What do I mean by splitting it up into 2 fractions? Well, when you have like 2 fractions and you add it together, let's say you have the same denominator, well, you add the 2 numerators together and keep the denominator the same. Well, guess what? Let's go in reverse. Okay, so instead, I'm going to have -4 over 2 as that first fraction, and then I'll have plus or minus here 2 root 2 as the second fraction over 2. And then from there, I can simplify what I want to do. Okay, so then my final result here, so because the problem is people just take -4 and 2 and then they leave this other part alone for whatever reason. I don't know why, but it's a common mistake I see. -2 plus or minus square root of 2. Absolutely correct. Yes. So again, just one of those things that once again I see quite often and want to nip it in the bud before it becomes a problem. So yeah, it's kind of important there. That's kind of a thing. It's those little things, they make a big difference overall. So quality of life and all that jazz. There we go. And we got our 2 answers. Perfect. All right, any questions about that? Math is about making small mistakes. Yes, I agree. But you know, the more practice and the more I point out what those mistakes that they are, then you know, the better you're going to get. So it's just things that I've noticed over time. You know, nobody's perfect, and I'm not going to expect you to be. So okay, fine. I don't expect 100% from everybody. How do you format the answer? You can format the answer by just separating it out if you want. So meaning to say, what I mean by that is like saying -2 plus the square root of 2, like this, and then put like a comma, and then put like -2 minus the square root of 2. So I'm pretty sure you can format it that way. Hey, take care, Blueberry. Come on back anytime, okay? You're always welcome. Yeah, those small mistakes can be a big difference because math has that cascade effect at the end of the day. All right. Oh, I'm not sure if we'll get to 2-1 today, but yeah, I think we're still going at a nice pace. All right. All right, let's go to the last question here of the handout, which is how do we solve quadratic equations by completing the square? Okay, so let's talk about completing the square here. Now, completing the square by itself, not the most fun of methods. It's a little laborious, even I'll freely admit that. But some concepts use completing the square here, so we do have to cover it. So that way we get familiarized about the process, about how to do so. So let's go ahead and pick out a problem here, and we'll see exactly how we can get it to work out. Okay. Oh man, it takes yeah. Oof. All right. Okay. So this one is, yeah, this one's pretty good. So this one you can easily factor, but I just kind of want to show off how we do it via completing the square. So I would be like 10 times out of 10, I look at this problem and I'd be like, oh, I can easily solve that using AC method or whatever. I'd be like, yeah, you're right. Absolutely 100%. All right, but we want to use a specific method here, completing the square. It's just knowing what the final answer is going to be and how to arrive at that same final answer here. Okay, so, all right. So x squared plus 7x minus 8 is equal to 0. Okay, so how exactly do we complete the square here for a process like this? Okay, so let's talk about the steps here. The steps here are going to be different than that of the AC method. So let's talk about the steps and go over one at a time. Okay, step one. All right, step one. Make sure that the coefficient of the x squared term is positive. All right, and more importantly here, keep all the x's on one side and the numbers on the other side. Okay, so that's step one here. So I'll showcase what that looks like here in just a second. So, okay, here we go. Okay. So what exactly do I mean by this first step? Okay, so by it itself, it's like not, it doesn't look so easy, but really, what am I talking about here? What I'm talking about here specifically is all I'm going to do here in this problem. Normally, we would get it and move like, normally we would just keep this and then factor and then do what we need to do. But what we want to do here in completing the square instead is we're going to go ahead and add by 8 to both sides. So we want the x's on one side and we want the numbers on the other side. So I'm going to add 8 to both sides, okay, through this process. So what I should have here is I'm going to have, I'll put this in parentheses here for a reason, but I'm going to have x squared plus 7x. That'll be its own little bubble, okay, its own little guy. All right, and that's going to equal 8. All right, so now it's in its own little bubble here. Okay. All right, so that's step one. Make sure that x squared is positive, or the coefficient. In this case, it is. And then we move the number to the other side. Solid gold. Remember, please ask questions if it's starting to get confusing. Okay, so if just stop me and say, hey, what do you mean by this? Just let me know. All right. Okay, let's go to step 2. So what do we do next? All right. So what we're going to do next is we're going to take b. All right. We're going to take b, divide it by 2, and square it, and square the result. Okay? So let's see what happens here in this case. Okay? So we're going to take b, we're going to divide it by 2 and square it. Let's look at this carefully. So I'll go over this very slowly. All right? So our b term here is 7. Okay, 7 because, again, 7x. All right, that's the b term here in this instance. So we're going to take 7, we're going to divide it by 2, and then whatever this is, I don't really care what it is, all I'm going to do is square it. Okay, that's what I'm going to go ahead and do. Okay, so if I square this, I'm going to get a result here of 49 over 4. Okay. So actually, what did I do here? Sorry. So this is what we're going to be doing here for step 2. Now, I want you, what's going to be important here is how I write out the work. All right, so I'm actually going to write out the work this way. There is a rhyme and reason why we're going to be doing this. No, I do not want it as a decimal. You'll see why. Okay, there is a specific reason why we want to avoid decimals at all costs. It'll actually make it significantly easier at the end of the day. There are actually a couple of reasons, but if we want like ease of use, definitely don't want it as a decimal in this instance, or most instances. Now, I'm probably saying, okay, let me go back to Desiree, your question there. Well, why don't we want it as a decimal? You know, what do we have? What do we do in order to, you know, what do we have to do? Why is that even the case? Well, the next step here is going to acknowledge part of that. So what you're going to do is you're going to add the result of step 2 on the left-hand side and the same amount on the right-hand side. Okay. So you're going to add the result of step 2 on the left-hand side and the same amount, notice I put same amount here in quotation marks, on the right-hand side. This will be this same amount here, as I'll talk about if I have time to do one more example, will become more apparent in the next example than this one. But it does make a significant difference in certain problems when completing the square. So I do want to point that out if I get to another example today. So in this particular case, all I want to do here is, with this equation here, I'm going to go ahead and add by 49 over 4 here. And I want to add by the same amount here by 49 over 4 on the right-hand side as well. The quote-unquote same amount. Now, why do I put quote-unquote same amount? I don't know if I'll totally get to that last part, that last example, but let me go ahead and point out why the same amount is in quotation marks. This is because the thing is that you want to be sure that this x squared in the front has to be 1, okay? So whatever this number is in front of x squared, you actually have to factor that out to start with. So if there was like a 3 out here, you're not just adding in 49 over 4 on the left-hand side. You're actually adding in 3 times 49 over 4, and that's what you would have to do to put it on the right-hand side to actually balance it out. Okay, so that's why it's actually important to say the same amount in quotation marks, because of that fact. You could have that extra factor in there. So there is, again, a rhyme and a reason why we're doing it in that method. I hope that makes sense. Are there questions behind that about that? Because that's usually the point of contention for most people. So I'll be doing an example of that. If I can't do it today, then I'll certainly do it. I'll certainly do it next time. Yes, we do keep the 7x. That is correct. Yeah, the only thing that I've done here is just add by 49/4 here. Yeah, it is pretty easy to forget. That's why if I do a second example, it'll make, 10 times more sense. Like you'll see it at actual action. So, that's the thing. All right. Well, that was a silly message. All right. All right, so now let's go ahead and write this down here. This is actually pretty important. So let's do this. Okay. All right. Step 4. So what is step 4 here? Now, step 4 here is we're going to do two things here. We're going to factor the left-hand side and add up the right-hand side. Okay, so nothing too hard here. Okay, in terms of the right-hand side at least, like left-hand side. Okay, not so friendly, I'm sure, with a fraction in there. Boo face. All right, so the right-hand side, you just add two fractions together. Let's see, what do we get there? 81/4. I think, yeah, 81/4 is what we get on the right-hand side. I'll come back to that here in just a second. Let's talk about factoring the left-hand side, though. You're probably wondering, hold up a sec. You got to factor the left-hand side? Are you joking? I got a fraction there. I got a 7 there. I don't know what the heck that factors to. I'll be like, all right, I'm out. Okay, you'd be like, no, I'm out. I need to take my, YouTube 3-hour break, and pray to the gods in those 3 hours, and then come back and be like, something like that. That would be me anyway. No, actually, factoring the left-hand side is actually easy. Actually, it turns out to be rather simple. Now, you're probably saying, whoa, 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 time out. That can't be true. But it is. Okay, so we're going to put a big key here in the factoring. So factoring key. The factoring key is this, is that the left-hand side will always factor to this. And I'll put this in the math type stuff. So it'll be x plus b/2 quantity squared. This will always factor to this guy. The way we set up completing the square, this always happens because of the intentional way we actually did the problem from the outset. It will always factor to this particular value. And what's very convenient for us here is all you have to do is grab, notice I put 7/2 in parentheses? Yeah, that was purely by design because I know exactly what's going to happen on the left-hand side for factoring. By default, this is going to factor to x plus 7/2 quantity squared. So no matter what's in that parentheses, in step 2, that's what it'll always factor to. And that's what makes the job a lot easier, is that I don't have to guess what it factors to. I already know from step 2. Okay. So again, you can get b/2 from step 2. So you can see here how things kind of work out in your favor. All right, where because of the way we set it up, then we automatically know what the left-hand side will factor to at the end of the day, which again is the nice, laziest method to do anything in life. Okay, so all right. Are there any questions about that particular step? I want to be sure that that part is clear. No, no questions? Okay. Okay. So to get 81 over 4 there, specifically, I just added 8 and 49 over 4 here. So 8 here, if you do common denominator for 8 here is going to be 32 over 4. That's if you multiply by 4 over 4. And then add that to the 49 over 4. Add that to 49 over 4. So basically all I did from here was do that common denominator stuff, with the fractions and not, 4 over 4 stuff. So that's how I ended up with 32 plus 49, which is 81. Yeah, no problem, Manfred. No problem, my dude. Here to help. Any other questions? What a twist. Thanks, M. Night Shyamalan. All right. So let's go to the next step here, the last step as part of this process here. Now, if you can see the way we factored stuff out, notice now it's a square root problem, just like we did from before. So now we can go ahead and step number 5. Nothing for mine, very good. Step number 5 is to solve for x using the square root property. So in this case here, let's go over this. All right. I'm so sorry. Yeah, left-hand side, right-hand side. Sorry about that. I abbreviate that quite often. My bad. Bad habit for me too. Bad habits for me. Sorry about that. My bad. It's on me. Okay, so solve for x using the square root property. So if we're going to use the square root property here, okay, square root property isn't too hard. We're going to just take from starting from here, just do what we did in the last problems and just take the square root of both sides. Okay, remember, plus or minus is in play, okay, for the right-hand side especially. So we take the square root of both sides respectively. Let's go ahead and copy paste that. Okay, so what we get here next is we're going to get x plus 7 halves, and I'll put that on the next line. X plus 7 halves equals, and then we get plus or minus, and the square root of 81 over 4, you can just separate it out as the square root of 81, which is 9, and the square root of 4, which is 2. So you can actually separate them out by the rules of square roots. Okay, and so we get plus or minus 9 halves. Now you have two equations. Okay, so you have x plus, you know what, I'll probably do it that way. Yeah, I'll do it that way, sorry. I just make it easier to read, sorry. So we're going to have x plus 7 halves equals positive 9 halves. All right. And x plus 7 halves equals negative 9 halves. Because again, plus or minus is in play here. All right. So that's how you can break that up into two equations there. And you will find two answers here for x, so let's go ahead and point this out. So for the first one here, if you subtract by 7 halves on both sides, all right, you get, let's see here, you get 9 minus 7, which is 2, 2 over 2, which is 1. So you get x is equal to 1. And then for the second one here, you also get x is equal to minus 9 minus 7, which is minus 16 divided by 2, which is minus 8. So you get 1 and minus 8 here. Like I said, we knew what the answers were because it's easy to factor. But again, here's another way to justify those. All right. And a way we can do it via completing the square at the end of the day. All right. Now, I'm kind of out of time. I wanted to do one more example here to show what happens when we have like a coefficient for x squared, the number in front of x squared not being 1. But I'll just show that off next time so you know how to make that adjustment. All right. Otherwise, I think next time we'll go a little faster. Sorry, I wanted to get to 2-1, but this a lot of this review material is so important. So, and I didn't want to go too fast where it kind of overwhelmed you guys. So I hope this pace that I took is good. At times I may go a little bit faster just to kind of get ahead, but I hope this pace is okay with you guys. It's fine? Okay. All right, cool. You know, last thing I want to do is make you feel like you're left behind, okay? Yes. So that is the end of Unit 1.5, okay? So Section 1.5, we're going to do one more example from that for next time. And we're going to get right into Section 2.1, 2.2, so that'll be on the docket here for next time. You have the handouts there online, so you should be good to go. So if you want to kind of keep up with the work, then the Unit 1 homework there on ALEKS should be the one that you should be doing at this moment in time. ALEKS homework is going to be due once I announce the test for Unit 1 and Unit 2. So I haven't announced that yet. Once I do, then the homework will be due that particular day when the test is. So just wait for me to make an announcement in that regard. Yeah, so you could take your own pace here. It's not like you're, it's not like I'm gonna super pressure you to get everything done right away. Okay. Alyssa, did you get my whisper there? is that little message box there. Oh, okay. Yeah, I was sure, sure. It's fine. Let me quick whisper you again. There we go. Sent it again. Um I think there's a link yeah, I put a link for Alex on the announcements page there, Chase. Or you could just go to Alex directly, alex.com, and then have your login stuff and all that jazz. Okay, cool. Is everything okay on your end, Alyssa? Were you were you able to? Hang on a sec. Okay, that's fine, Desiree. All right, no, all right, that's okay. I know that things are a little slow, so I'm not gonna hold it against you if you didn't get it right away. So, um, oh, that's okay. That's okay. Just let's just do it in chat. Were you able to keep up without too much trouble there, Alyssa? I want to be sure that I know that you're having some connection stuff, but were you okay with the material there? At least from the parts that you were able to hear. Okay. Okay. Good. Good. I was a little worried because you were silent a little bit, so I was like, oh, hopefully you didn't fall too behind. Yeah, I know, but that the bookstore is always going to charge more. It always marks up the prices of everything. You're talking like 30 to 50%. So yeah, don't expect the bookstore to be cheaper. That never happens. Yes, and that's the key. That's the reason why the bookstore charges more because of financial aid. Oh, that's cool. Yeah, that's why the bookstore takes that premium, right? Because it's the financial aid. It's the financial aid money. So that's why they charge more. It's a way that they can weasel a few extra dollars out of you. Trust me, I'm not too happy either. I'd rather save you money, but you know, it is what it is right now. Oh, okay, yeah. Yeah, you can't look around the bookstore. Even with financial aid, my wallet cries. Oh my gosh. Yeah, of course it's so of course you may leave, absolutely. Um yeah, so this stream will be up right after I end the stream. So yeah, immediately right after I end the stream, you can rewatch the stream. Um, and then 24 hours after that, I will be posting that on YouTube, so has a permanent home. Um, I posted the first 112 lecture, so there you go. No problem. Thank you very much. And I hope let's got to end off here for today. I hope everybody has a very wonderful weekend. Okay, we're gonna come back here on Tuesday, same time, same place. Okay, everyone, have a wonderful weekend. Stay safe and stay healthy. All right. Again, you know where to contact me if you need to contact me. All right. Have a great day. Have a great weekend, and we will see you all later. All right. Bye.